one of the biggest questions in our field is what would happen if the Carrington event happened today? And actually, the activity of the sun is dictated by what we call the solar cycle. So every 11 years, we will have the sun alternating between a state of being a bit more quiet, which we call the solar minimum, and a state of being much more active, which we call solar maximum. So a solar flare is this very rapid burst of energy, of magnetic energy that we see as a very fast brightening on the sun that can last from a few minutes to a couple of hours. And from there, yes, we get radiation coming out in the solar system. And at the same time, we can have also a so-called coronal mass ejection, or CME, coming out of the sun. And that's literally a cloud, a huge cloud of plasma and magnetic fields that can be thrown in any direction. So sometimes it's going to miss us, but sometimes it's going to directly impact us. But what else can come when a coronal mass ejection with a southward pointing magnetic field comes towards us is that we get all these extra particles, extra currents coming in. So we will have elevated currents on ground, which can disrupt things like power lines and energy transformers, all these technology things that we are so accustomed to right now.
Biggest solar weather event we've ever been hit with. What did it do?
Let's start. Yes, history. So if you have ever, like if you're like a space weather enthusiast, or if you know a bit about the sun, you must have heard about the Carrington Event. Which was literally the biggest storm, geomagnetic storm that we have had to date. Now, this storm happened in September 1859. Now, as I said, solar eruptions, we have flares and CMEs. They can happen separately, so we can have only a flare, we can have only a CME. In the strongest eruptions, they tend to happen together. So you have the brightening from the flare and the cloud coming off. The cloud, CME, coming off and hitting us is what drives then a geomagnetic storm, which is when I said we have the magnetosphere peeling and opening, we have all the particles coming in, we have auroras, we have extra currents going on ground. So that's all parts of a geomagnetic storm. So the cloud that was released at the eruption that Richard Carrington saw via the flare arrived to us pretty quickly, I think in about 1 day. So the telegraph system all around Europe and the Northern America completely failed. So there are even reports of telegraph operators disconnecting the machines, and the machines were still sending messages. One of the biggest questions in our field is what would happen if the Carrington event happened today? Because back in the day, the damage couldn't be that huge because we only had the telegraph. Aurora was seen until the Caribbean. So there are reports from Mexico, from Cuba, and people said that they could just read the newspaper at night because of the aurora lights were so bright. But as I said, from something like that, there is absolutely no direct damage to the human body, only to the infrastructure.
So when I think of like measurement, right, like I'm thinking of kind of along the lines of like the Richter scale, right? So if you took this event, is it Covington or Carrington? Carrington, a mix of both of those, right? So where would that be on kind of like the measurement scale?
Okay, so that's a very nice question, because our scales do not like, there is a top, and above that it's still gonna be that. So I'm pretty sure it would. So for example, for geomagnetic storms, the official scale from NOAA is from G1 minor storm. I mean, obviously when there is no storm, it doesn't have a name. G1 minor storm to G5 extreme storm. So I'm 100% confident the Carrington event would have been classified as a G5. But we don't have anything above it. So the strong ones, they're still going to be called G5 because the scale just doesn't go.
Right. It doesn't matter if it wipes the Earth out. It's still a G5.
And I mean, it's a bit the same for flares, more or less. So flares. Okay, let's only talk about the decent ones because the scale goes very low and for things that we can barely see. But we have C flares, very weak, M flares, kind of medium, X flares, very strong. But they go on a logarithmic scale. So, an M flare is 10 times more powerful than the C flare, and the X flare 10 times more powerful. And then they have numbers inside. So you can have X1, X2, X3, X4. But for example, for M, you go from M1 through M9, and then you get to the X class. Well, the X class just doesn't end. So it has been estimated, obviously, from drawings done 150 years ago, that the Carrington Event flare could have been something like X46, which is kind of crazy. but yeah, it would still be an X flare because the scale just ends.
Man. But there's no indication that, like, okay, this happens every so often. This happens every, like an earthquake. Like, all right, well, every 300 years, we're going to get another one.
I mean, the estimate is that this kind of very strong events should happen once every more or less 150 years. So it's time now. No, I'm joking. But the point is that, okay, even if it happens, it could happen on the far side of the sun and just not come to us at all. So there has been in 2012 a pretty strong CME launched from the sun, but it missed us because it was just not launched in our direction. Yes, the sun will pretty for sure have another huge eruption. When, we have no idea, and in which direction, we have no idea. So it could happen tomorrow and miss us.
It kind of sounds to me like we should be very afraid and not afraid at all, right? Like it would ruin society, but we would live through it at least if we...
Oh, I mean, yeah. I mean, humanity survived for millions of years without even knowing about solar activity. We didn't have technology back then, but we survived, yes.